Here we go. This is take two for this Peierls instability of linear metals in brief. Consider a one-dimensional metal with an electron gas-filled all conduction band out to the wave vector kf at absolute zero of temperature. ठीक है, तो ऐसा सॉलिड है जिसमें ये इलेक्ट्रॉन गैस का बिहेवियर है इलेक्ट्रॉन्स का, और जो कंडक्शन बैंड है उसका ऑर्बिटल्स आर फिल्ड टिल के एफ wave vector at absolute zero temperature. The Peierls suggests that such a linear metal is unstable with respect to static lattice deformation of wave vector this g is equal to 2kf. ठीक है, तो ये होगा सच ए डिफॉर्मेशन क्रिएट्स एन एनर्जी गैप. तो अचानक से जो ये डिफॉर्मेशन होगा 2kf का, इसमें ये इन अनस्टेबल हो जाता है. सो डिफॉर्म के एनर्जी गैप ऑफ एट द फर्मी सरफेस. सो डिफॉर्मेशन क्या करेगा, एनर्जी गैप एट फर्मी सरफेस लाता है, thereby losing the energy of electrons between below the energy gap. Okay. Okay, says electronic energy कम हो जाता है, क्या मतलब? The deformation proceeds until limited by increase of elastic energy. Deformation proceeds until limited by increase in potential energy, or increase in elastic energy. Maybe like a गुलेल. The equilibrium deformation is given by, तो ये है, इसके बाद टूट फूट हो जाएगा, d by d delta of electronic and elastic, दोनों इलेक्ट्रिकल एनर्जी या इलेक्ट्रिक फील्ड का सम का ये d by d delta. Consider the elastic strain is delta cos 2k fx. So this is a strain. Delta cos 2k fx. The spatial average of elastic energy per unit length. ये नया नाम है इलेक्ट्रिक फील्ड का. Spatial average elastic energy per unit length is equal to elastic half of c delta square average of क्या है, average of cos square 2kf, average of cos square 2kfx is equal to 1 by 4 c delta square, where c is the force constant, CFC force constant of linear metal. We next calculate electronic. Suppose the ion contribution of lattice potential seen by conduction electron. Contribution the lattice potential seen by conduction electron. Contribution by lattice potential. So lattice के वजह से जो नहीं, आयन की वजह से जो lattice potential है, आई डोंट नो व्हाट इज लैटिस पोटेंशियल, बट आयन की वजह से कुछ है, तो मे बी पॉजिटिव 4 के बारे में बात कर रहा है. डिफॉर्मेशन इज by such seen by conduction is this u. So ये एनर्जी है तुम्हारा u of x is equal to 2a delta cos 2fx. So 2a delta cos 2k fx from another chapter. We have ek equal to this. Okay, ek is equal to h square by 2m into the sum plus minus this product and sum under root में. Here apart. This is convenient to define. X is this, h square, so x goes here, xf is equal to k square h square k square f by m. So that will go here. यहाँ पे नीचे में 2m मतलब by 2 आएगा कहीं पे, और this h square kf by m. This, I don't know what that is, but okay, that is x. Xk, xf, and x. We retain the negative sign, so d d delta is this minus a square delta by kfx प्लस ए स्क्वायर डेल्टा स्क्वायर अंडर रूट में ये वाला चीज नीचे डिनोमिनेटर इसका whence dk as a number of orbitals, dk by pi is the number of orbitals, so d electronic by d delta is equal to 2 pi kf dk into d this, which is equal to this नेगेटिव यहाँ पे माइनस और ये डी के अंदर में नीचे में के एफ वाला कुछ समेशन है दिस वाला डिनोमिनेटर वही है ठीक है ये नीचे में पाई अभी भी है डिनोमिनेटर में so we have the final equation this 2 alpha square something kf by sine hyperbolic inverse of xf by a delta. You put it all together, we get what do we get? This goes here and this is here. That is from before. Both are E. Okay, so E ये वाला इक्वेशन है, E electronic, E elastic. एक मिनट ठीक है तो this first term is elastic, this is electronic. The root delta of the corresponding to minimum energy is given by this. Whence this A, I don't know what is A. I have to go to this chapter. So out the argument of A argument, okay, this thing argument of psi is much greater than 1, we assume kf is less than half of k max. The result is from the energy gap equation is in BC's theory of superconductivity. The deformation delta is collective effect of all the electrons. So note this, collective effect of all the electrons. If we set W equal to h square kf square by 2m is equal to conduction bandwidth n equal to 0, n of 0 is equal to 2m by pi h square kf, the density of orbitals Fermi level equal to density of orbitals at the Fermi level. V is equal to this, the effective electron energy. We have this, which is analogous to BCS gap equation. Example of Peierls. Okay, that is Peierls instability. Don't know how to write this, but okay.